All right, good morning, everybody. How are you today? I hope you are doing absolutely fantastic, awesome, rocking and rolling, moving and grooving, going with that flow, riding with the tide, and shaking with the bake. So, what do we begin with today? Well, other than hoping that you had a great weekend, we begin with Lesson 8, the homework answers. So, given that you're watching the video, we won't be able to have a give and take on this, but I will show you the answers in case you have any questions. You can always email me, which a few of you have, and that's a really cool thing. Go ahead, take a look at those answers. Do stop and start with these frames, and I'll come right up with it in a second. Okay. Again, stop and start. And there's your graph. And here are your simplified laws of exponents problem, the new material that we covered last week. Okay? All right. So what's up next? What's up next is the pregame stretch. So what I'm going to do here is, you can do a snapshot or freeze your screen. Go through these questions, get those answers. I'll scroll it up in a second. Get a snapshot, graph, and get a snapshot. All right, and then you just go through these, wherever you stop and start the videos or whatever, and get those questions done. And then here are the correct answers to the pregame stretch. And again, if you have any questions, you can reach out to me. I did graph numbers 1 and 2 both ways, one with the circle method where you fill in the circle or leave it open, and the other with the bracket or parentheses. So check your answers, see how you did. I would like to call to your attention something on number 3. It says, what's the largest integer that is a solution for 4 times, in parentheses, 2x minus 3 is less than 20? And it works out that x is less than 4. So 4 is not a solution. We've been over that a lot. Now, the largest integer that would work, now remember, what are integers? Integers are like 1, 2, 3, 4, 5, positive and negative and 0. So what we have here is, if the answers must be less than 4, then the largest integer that is less than 4 would be 3. So that's why it's 3. Okay, these are pretty straightforward. Again, I would suggest stopping the screen if you haven't done so already. Okay, so a couple I'd like to call your attention to. Letter D. It's 1 over 5n to the third, and whenever this you get an exponent in the bottom like this, n to the third, another way to write that is n to the negative 3. A negative exponent means reciprocal. So if I write the n in the top, as I did here in the second form, see where my cursor is moving, n to the negative 3, that means 1 over n to the positive 3. And that's what we have here, 1 over n to the positive 3, I wrote as n to the negative 3. Okay, I'm not sure if you recall that from your high school days, but that's how it is. Okay, and here is the graphing systems question done for you. All right, so that reviews the material that we had before us. A little look at where we're going with this. Now, these videos will be used in subsequent years, but the lesson numbers won't change. Only the dates will, and the approximate dates of quizzes. I want you to notice you have a quiz this, it's going to be, let's see here. It's going to be on Wednesday that you have a quiz this week. Pretty much every Wednesday you have a quiz. As you can tell, they go every other lesson. And this week we're studying polynomials. So that's what we are going to get into this week. Next week we're going to get into factoring and then solving quadratic equations and then functions and inequalities. We've already covered a lot with inequalities, so we'll probably do some more stuff with functions then as well. Okay? All right. Lots of work with functions coming up. Functions are really, really, really critical for the understanding of mathematics. Okay, so now let's do the review section, which I think is the first 13 slides, I think. Yes, the first 13 slides. So, okay, today's lesson will be all about polynomials. We're up to lesson 9. There's a total of, I think, 31 different lessons, but some of them are test days, so we're rocking along here. We're getting into the meat of the course. Our agenda for today: homework review, did it. Pre-game stretch, end review, did it. We're now up to the recent work recap, and then the first lesson in polynomials. So let's see you solve for the variable. Of course, do stop and start. I know it's a sad day because after this, I don't think there are any more. We've cut back on a lot of the previous review material now that we're past the test, as you shall see. Okay, if you hear the hum of sound in the background, my wife, she loves our zero-turn mower, and she is outside cutting the lawn. It's very difficult for me to even get a turn on that thing. She loves it so much. All right, first one, distributing the 4. Combining like terms here, 8n, 4n is 12n. Remember that term because we're going to talk about it today. That's what it was when we said same side, same operation. It was really a euphemism, if you will, for combining like terms. Negative 12 and 1 make negative 11. Add 11 to both sides. Divide by 12. N is, or H is, it should be N, 3. Okay, on the right-hand side, distribute. Opposite side, opposite operation. 3x plus 6 is 21. Opposite side, opposite operation with the numbers now instead of the letters. Don't know if you ever looked at it that way. 3x is 15. X is 5. It says K because that was the old letter. All right. Any questions? Make sure you reach out. Let's try this one, a little more involved. Okay. You should have had time to get it done, considering that you should do stop and start. Distributing 12n minus 28. Distributing again, minus 3n minus 21. Minus 4n equals 2n plus 2. Same side, same operation, which means to combine like terms. 5n minus 49 is 2n plus 2. Opposite side now, subtracting the 2n, 3n minus 49 is 2. Adding the 49, 3n is 51. Dividing, and you get n is 17. Okay. Literal equations. Let's do 2 of these guys. In the first one, it's the same equation in both cases, but I really wanted to emphasize that you can take any equation and you can solve it for any variable, giving those equations great power. That's what we do when I've mentioned multiple times in multiple courses, for that matter, that with the Fahrenheit Celsius conversion, I only remember one formula. I don't remember 2 different formulas. That way I can just, solve for whichever part of it I need. All right, so in the first problem, you're going to solve for A, make it say A equals. And in the second one, you're going to solve for Y, make it say Y equals. Now let's do this one step at a time and do just the first one. Go ahead. Okay. So solving for A, I got to get it all by itself. So I'm going to add 15b and subtract 35c from both sides. That gives me 5a equals 10y squared minus 15b minus 35c. Divide everything by 5. And I get a equals 2y squared minus 3b minus c. So now you're going to take the same exact equation, but this time you're going to solve for y. Go ahead. Okay, so if you're solving for y, you need to divide everything by 10. Okay, so that's what y squared equals, but I want to know y. And the thing about it is, when you solve for y out of a y squared, you've got to square root both sides. So y will equal the square root of 5a minus 15b plus 35c all over 10. Excuse the yawns. Don't even know why I'm yawning. I got a good night's sleep last night, 7.5 hours, which is plenty for me. Don't understand, but it is what it is. All right, 3 inequalities to solve. Solve them all. Solve them, graph them, represent them in notation. Go ahead. Okay, so we are doing stop and start, so you should be done. If not, pause the video till you are. First one, subtract 20, divide by -3. Don't forget, when you multiply or divide by a negative, you got to switch the inequality. N is greater than 1. There's my graph. And, oh, I guess I'm going to do the notations at the end. Next one, distributing the -5. Combine like terms now. That's -17x is on the left. Plus 82 is less than or equal to 7x plus 10. Always start with the smaller number of extras, which is going to put us in a little bit of an awkward position. Add 17x. I get 82 is less than or equal to 24x plus 10. Subtract 10 from both sides. 72 is less than or equal to 24x. Divide by 24, and I get 3 is less than or equal to x. Now, what's awkward about that is with inequalities, we really strongly prefer to have the variable on the left. So if it points to the -3 here, when I put the variable on the left, it has to continue to point to the 3, pardon me, if it points to the +3 here, it's got to point to the +3 here. And that makes really the same kind of statement. I mean, think about if we were just speaking, about something with which we're very familiar and not something like algebra. Let's say we said that Johnny is smaller than Jimmy. Well, I could also say Jimmy is bigger than Johnny. It's the same statement. Johnny's smaller than Jimmy. Jimmy's bigger than Johnny. 3 is smaller than or equal to x. X is bigger than or equal to 3. Same exact statement. There's my graph. Remember, we graph the one on the right, the expression on the right, because the x is on the left side of the inequality. That's what we always want for graphing purposes. See what we did in number 1? The n was on the left. Arrow goes in the same direction as the inequality. On number 2, we converted it so that the x was on the left. Arrow goes in the same direction as the inequality. Okay, next up with number 3, subtract the 7, multiply both sides by -4. Since I'm multiplying both sides by a negative, that means I need to switch the direction of the inequality. X is greater than -12. Okay, there's my graph. As far as notations go, I have from 1 to infinity, with a parenthesis at 1 because you're not allowed to equal 1. A bracket at 3 to infinity because you are allowed to equal to 3, so you put a bracket. And very similar to number 1, but starting with -12 for number 3. Okay, so we're starting to wean ourselves off of these inequalities. Okay. All right, so interesting kind of question here. We've started to talk about them on the pregame stretch. Determine the smallest integer that makes this true. Okay? Go ahead, solve. Remember what integers are. Okay, so we solve it. I get -8x, because we're combining like terms here, plus 7 is less than 15, minus 7. -8x is less than 8. Dividing by a -8. Danger, danger, danger. Don't forget to switch that inequality. X is greater than 1. So, what's the smallest integer that makes this true? It's 2. Because 2 is the smallest integer that's greater than 1. Okay? All right. So this is just a little bit of a different slant on solving inequality questions. Okay, let's express all of these. You're going to do all 5 of these questions in interval and bracket notation. Go ahead. Okay, I just want to go through this. We'll do one, and then if you notice you did something wrong, go back and adjust your answers that follow. Okay, so the first one, the bounded interval goes from -8 to 2. That's why -8 and 2 are the critical points in here, the critical numbers. And in this case, they're both open circles, so you're strictly less than. If you fill them in, you would be greater than. Okay? So if that causes you to make any adjustments to your next answer, do so. If not, in the second or two, I'll put the answer up. Okay. So in this case, n is going to be less than -2, or n will be greater than 5. And there's your notation with over intervals to show it. Okay. Next one, from 1 to 4, but this time you are allowed to equal it, so it's less than or equal to on both sides. This, whenever it's, look, in the first one and the third one, they're bounded intervals. They have a beginning and an ending point. So whenever that's the case, in the middle, you're always going to have a less than and less than, or less than or equal to and less than or equal to, or some combination thereof based on whether the circles are open or closed. The problem is if they point in opposite directions. If they point in opposite directions, you can't be both things. There is no bounded interval. They go on forever and ever, and that's when you're going to use the word or, like in the middle question. In this particular case, you can equal the 1, you can equal the 4, so they're both brackets. We take a look at the next one, and again, it's a bounded interval, so I'm going to have the n and the inequality symbols, but I'm not allowed to equal either of them this time because they're both open circles, and the critical points, the beginning and ending of the interval, are 3 and 7, and the parentheses shows that they can't be equal to them. Okay, so when we look at the next one, we automatically know it's an or statement because they're pushing out to the sides like that. I used to, when I taught kids this for the first time and they were younger than you guys are, I would always say, it's kind of like that old MTV video, I think by the band The Bangles, where they go, walk like an Egyptian, and they would push their hands out to the side. So that might, if you've seen the video, that might be a mental image that can help you out. So you're going to be less than 2 or greater than or equal to 6. So there's my symbol, n is less than 2, or n is greater than or equal to 6. And there's my notations. Notice the 2 is in a parenthesis and the 6 is in a bracket. Infinities are always parentheses because you cannot equal infinity. So if you can get all of those questions right, you're great at your notations. All right, let's solve this system of equations graphically. Go ahead. Okay, so with the first one, the slope is 4 and the y-intercept is -1. That'll be the green graph. I touch at -1. I go up 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And connect the dot. There is my first line drawn. For the next one, I've got to solve for y. Make it say y equals. So, first thing I do is subtract the 3x. Then I divide by 2, and I get y equals -3/2 x plus 10. So the slope is down 3 over 2, -3/2, and the y-intercept is 10. So there was the blue line. I begin at 10. I'm going to go down 3 over 2. That's always comforting because I land right on a point. Down 3 over 2, down 3 over 2, connect the dot. And there is my point of intersection, 2, 7. Okay? If you check it, you will see that it works. Any questions? All right. Now we're going to do a little word problem with simultaneous equations. Go ahead. Okay, so I'm assuming that you did stop and start. So 2 popcorns and 3 drinks is $18.25. 4 popcorns and 2 drinks is $27.50. Now that I have my equations written, I need to get rid of one of the variables. In this case, I'm going to get rid of the p's. Usually I do the middle variable, but this time I'm going to do the p's. The trick still works where you could do 2 on the bottom and 8 on the 4 on the top and 2 on the bottom. But in this case, I noticed, least common denominator ways here, that if I just double the top one and negate it, my p's match up. So that's all I did. Distributing that -2 to the numerator, the top equation, I get -4p minus 6d is -3650. 4p plus 2d is $27.50. -4d is -$9, and I get d is $2.25. Okay, next up, substitute that d in for the drinks and figure out p. So I'll use the top equations. You could use either one. 3 times 225 is 675. Subtracting it, I get 2p is 11.50. Dividing by 2, and the cost of a pretzel or popcorn or whatever it is in this problem, popcorn, it's $5.75. That's some pricey popcorn right there. How's that for alliteration? Okay? All right. Solve the following system of equations algebraically. Go ahead. Okay, so hopefully what you notice here is that it's not elimination, because though the x's line up, the equal signs are not lining up. So I am going to, the thing that's a little different about this, and I really wanted to bring your attention to it, is that it would be really difficult to do substitution, because to get x equals, I would have to divide everything by 4. And then I would get that x is equal to 5y over 4 plus 11 3/4. And then I would have to substitute that in with the 6. That gets really, really ugly. So instead, I'm going to convert this to elimination technique. And for those of you who prefer elimination, this might help you out. The first thing I do is subtract 5y from both, and that gives me 4x minus 5y is 35. Now it lines up perfectly with the 6x plus 7y. That's not supposed to be a plus sign. That's supposed to be an equal sign right there. You'll notice on your laptop that the plus is above the equal sign. So I guess I forgot to hit, I guess I accidentally hit shift. So now I can multiply the top one by 7 and the bottom one by 5. I just copied that. That's why it's still there. So it should say equals 9, just to be clear. Distributing 28x minus 35y equals 245. And now the equal sign appears. 30x plus 35y equals 45. And it's just business as usual. So the really big trick here is if you get one that looks really awkward to solve for with substitution because you're getting fractions and decimals or anything like that, you can always manipulate either equation so that your x's are over your x's, your y's over your y's, and so on. Adding them up, 58x is equal to 290. Dividing, x equals 5. I can use either equation now to go back and get y. I'll use the bottom one. 6 times 5 is 30. Subtracting 30, I get negative 21. Dividing by 7, and I get y is equal to negative 3. So x is 5 and y is negative 3. Pretty slick trick there for you, and you can use it at will. You should know how to use substitution and elimination by now. And if you have a preferred one, and if that preferred one is elimination, or you may prefer substitution until you get to the point where you have fractions and decimals in the problem, then you can always do this technique of manipulating the equations so that they line up and you can use elimination. Okay, a little review of the laws of exponents. They were x to the a times x to the b is x to the a plus b. So x to the 5 times x to the 2 is x to the 7. We gave you the explanation last week. I won't do that again. It's the same exact slide I gave last week. X to the a over x to the b is you're going to subtract them. X to the a minus b In the example, x to the 6 divided by x to the 2 is not x to the 3. You subtract them, it's x to the 4. And the last one, x to the a to the b, is x to the ab. So if I got 5x squared to the 4th squared, I got to square the 5. That's, you square the coefficients. That's business as usual. That's 25. And x to the 4 to the 2, now I get x to the 8. In other words, whenever we're dealing with the common or same base and how to deal with exponents, I'm going to take it a step down from whatever the main operation seems to be. So a step down from multiplication is addition. A step down from division is subtraction. And a step down from raising a power to a power, you'd think you're exponenting here, that's multiplication. Okay? So remember, multiplication is repeated addition, I go with addition. Division is repeated subtraction, I go with subtraction. And exponentiation is repeated multiplication, I go with multiplication. So there we go. Those are the rules for laws of exponents. Let's try these questions. Go ahead. Okay, so for number 1, that's negative 6 to the 7th, right? Keep the base the same. Some students might think it's 36 to the 7th. That's not so. When we did that law that said x to the a times x to the b, it was x to the c. In other words, that base stayed the same all the way through. Again, x to the a, x to the b, x to the c. Let's go back and look at this here. Ready? See, here's my common base. Think of x as anything, because that's what a variable represents. So anything to the a times that same anything to the b is going to be that same anything to the a plus b. In other words, the base stays the same throughout the problem. So that's why the base stays the same throughout the problem. The answer is negative 6 to the 7th power. Next one would be negative 24, 8 to the 10th. Multiply coefficients, add exponents. Again, number 3, multiply coefficients, add exponents. Negative 35 for the A's, 4 plus 1 is 5. For the B's, 1 plus 4 is 5. And for the C's, 3 and 2 make 5. So it's negative 35, A to the 5th, B to the 5th, C to the 5th. Now, before you go do the next ones, if you got numbers 1, 2, and 3 correct, maybe, and you already did the rest of the questions on the right, fine, then you're done. If you got any of them wrong, maybe you want to go back and analyze numbers 5 through 18. Okay, so number 5, that's a 3. You're going to take what's in the parentheses and cube it. That's the 3rd power. So 5 squared cubed is 5 to the 6th. Number 6, x to the 4th to the... Well, that's weird. I can't even read what that says there. I read it before. Well, I don't know. Just kind of skip over 6. Next one. 2 cubed is 8, x to the 3rd. Why does that say 6 there? Let me go back. I can't really go back. I don't know why that says 6 there. It should be 8x to the 3rd as I look at it. Okay, so that should be 8x to the 3rd. Next one, x to the 12th, y to the 15th. X to the 12th, y to the 15th. And now let's take a look at number 15. 2 over 16 is 8, and the 8 goes in the denominator. I think that's a 5 over 4 for 1. It might be a 6 over 4 for 2. And then 4 over 1, or 5 over 1, I'm sorry. So that's x, because it's 5 over 4, so that leaves x to the 1st. Y to the 4, because that's 5 over 1, over 8, because there's 2 goes into 16 8 times, but it's in the denominator. Next says 3 to the 5 over 3 to the 7, which is 3 to the negative 2, or it's also known as 1/9. When you have a negative exponent, that means it goes in the denominator, as we mentioned before, so 3 squared is 9. Next up, 4 over 5 is 20. This should say 1/5 y to the negative 2. I'm going to have to correct these in the regular slideshow. 1/5 y to the negative 2, or 1/5. The x's cancel each other out. There's the same number of them. It's x to the 5th. And then y to the 2 over y to the 4 is y to the negative 2, or put the y squared in the denominator. And number 18, 12 over 3 is 4. And that would be x to the negative 3. And the y squareds cancel each other out. Remember, x to the negative 3 is x to the 3rd. Okay, that is our last slide of the slideshow, video 1. And then I will correct these for when I present it to the class.